Welcome to another episode of Python tutorial series. In this episode, I want to talk about array operations and broadcasting. Array are generalization of the numbers, so everything we do in numbers, we try to extend this to array. For example, multiplication, division, adding or subtracting array. But first, let's start with importing NumPy as NP and give you some example. If two arrays had the same shape, I can add or subtract or multiply or divide array, but in the division that we cannot divide by 0, so we get value error in this case. But if I have an array of shape 2 and 3 and I let me change it to comma. If I have a 2 and 3 array and I want to add this with another 2 and 3 array, which means the first array has a shape 2 and 3, the second one has shape 2 and 3, and two of this array has the same shape, the result is an array of shape 2 and 3. Let me show you an example. For example, I have an array A, np dot array, or I can say np dot ones, shape 2 and 3. It's faster, and B np dot ones of shape 2 and 3. And I want to calculate A plus B. The result is 2, 2, 2, and we can see that it is true. And here A plus B means component wise of A and B. But if I, for example, multiply these two or minus these two, the result is 0. And if I multiply, the result is 1. And you see the operation here is component wise operation. For example, it means the first element from the first row and the first column of the first array multiply to the first row and first column of the second array, and so on. So maybe let me define another array C, which is np dot array 1, 2, 3 and 4, 5, 6, and another array D to that array 1, 2, 3, 7, 8, 9. And if I calculate C plus D, we have this result. We can verify it, and the multiplication is the same, and division also is the same. But if I change, for example, the second member of the array to 0, then I will get the value error because I divide 2 by 0 in this example, and you see this one is that didn't get the value error. It gives me infinity, which is true somehow, but we have this warning that divide by 0 and 100 in the true divide, which means it gives me infinity, which is not the case if I change 2 to 0 and we divide 0 by 0, which is none in this case, and it means that we don't, the value is unknown, and we should be careful about this operation. But we could have other aggregate function like sum, maximum, or minimum of an array. For example, for array C, I can say that np dot sum of C is 19, but I can do the sum operation on different axes. So for example, if I say I want the sum of arrays C on axis, for example 0, it means that I want the sum of the rows in C. So the first row is 1, 0, 3, the second one is 4, 5, 6. So I add this row component wise, and I will get an array of the same shape, which is 3, and the result is 5, 5, 9. And you can see 1 plus 4, 0 plus 5, and 3 plus 6. But if I change axis to 1, it means I want the sum of the columns of C. So in this case, I will get 4, 15, which is the sum of the first column, 1 plus 0 plus 3, and 4 plus 5 plus 6. And you can see that we could have control over axis to get the sum. We have another function like max, which gives me the maximum element in C, but if I don't fix the axis, it gives me the maximum absolute maximum value of the array. But if I add axis here, for example axis 0, it gives me 4, 5, 6, and if I change the axis to 1, it gives me 3 and 6, which is the maximum value between the column. And we have the same operation for min function and so on. So far we deal with the operation on array with the same shape, but we could have operation on array with different shapes, but we need some constraint, and it is not true that any two different array with two different shape can be added or multiplied. There is some condition that need to be satisfied, and this is the concept of broadcasting. In array, we need to add array with array, but with broadcasting, we could add numbers to an array of shape, for example 2 and 3, and the result is an array of 2 and 3. In this case, this single numbers adds up to any member of this array, and the result gives us another array. For example, let me bring C here to I want to add 3 to this array C. You can see that 3 added to each member of this array. But we could also have array of, for example, I have an array of shape 3 and 3, and I can add this array to an array of shape 1 and 3. So what's happened here? I have 3 rows and 3 columns, and I have another array of 1 row and 3 columns. The second array duplicates itself somehow to change 1 row and 3 columns to 3 rows and 3 columns. So let me maybe change 3 to 4, 3. So what is common here is the number of columns in these two arrays. So I have 3 columns for the first one, 3 columns for the second one, and the array extend to 4 rows, the second array extend to 4 rows to have the same shape as the first array, and the result is as the previous case when we have the regular array with the same shape. Let me explain with an example. For example, I have an array X. I can overwrite on A. For example, I have an array A, np.ones of shape 4 and 3, and I have an array B of np.array, for example, 1, 2, 1, 2, 3, and I want to add A plus B. The result should be 4 and 3. So in this case, you can see that the result is 4 rows and 3 columns. And we can see that 1 to 3 extended to a 4 by 3 matrix, which each row is 1 to 3. So the algorithm copies 1 to 3 4 times and then stack it on rows and adds the result to A. But we could also add array of shape, for example, 4 and 1 to an array of shape 1 and 4 or 1 and 3. But the result here is like this. The first array extended to the 4 rows and 3 columns. So we have a column vector and we copy this column vector 3 times to have an array of shapes. So the first step here is that the first array extended to 4 and 3, and then it adds to 1 and 3. So in the second phase, 4 and 3 stay same, but 1 and 3 change to 4 and 3, and the result is 4 and 3. Let me show you in an example. I have an array A, np.array, for example, 1, 2, 3, and 4. We have a 4 by 1 array, and I have another array Y, which is np.array 6, 7, and 8. I can add X and Y. I can see the result is 4 and 3. And the processes look like here, as I mentioned. The first array extended by copying the first column 3 times to have 4 by 3 matrix, and then the second element broadcast on rows and copy 6, 7, 8 2 times to have, sorry, 3 times because we need to have 4 by 3 matrix, and we have 2 same shape array, and we could do the regular operation on this. And this is a broadcasting, we call it broadcasting in Python because we broadcast rows or columns depending on the application. Thanks for watching this episode. In the next episode, I will talk about more details of the NumPy array to do more advanced stuff.